Okay, welcome to the next video in the systems programming video series. We're picking up in this jam coding session from last time. So we're moving on to problem number 2. Might as well go ahead and write that. And we'll start with part A. What is this floating point number written in hex digits? What is the number in binary? And that's pretty straightforward. So we could just take every one of these hex codes and expand it individually into 4 bits. So that first 0 would be just a sequence of zeros. I'll go ahead and comma separate them, although that's not meaningful. That's just as a visual aid. So that would be just the number 0. Like in binary with 4, the hex number 0 is the binary number 0, which is all zeros. Very straight. Sorry, I'm reading the wrong thing right? That's just symbol to indicate that we're reading a hex number, but I should be starting here. So what is the value C? A is 10, B is 11, C is 12. So then we want to write down 12 in binary. And so I know I'm going to need 8 and then another 4, and that's it, right? So that gets me 12. So there is the binary version of the number 12. I'll write a comma just as a visual aid to separate these things out. The next number is 0, so that's just all zeros. Okay, next, we're going to write the number 3, which is going to be just 0, 0, 1, 1, and then all zeros, 1, 2, 3, 4. Okay, then all zeros and all zeros and all zeros. Okay, so there's the binary number. Label the sign, exponent, and significand. Okay, the sign is the leftmost bit, and so the sign is 1 indicating negative. The exponent is the next 8 bits after the sign, I believe, right? Let's just double check this right. So the sign is the leftmost and the exponent is the next 8. So in this case, if I just, well, let's just select 8 bits, right? So that right there. So those are the bits. We might as well just reorder that. So there's the exponent and then the significand. And do we want to maybe just say, what is this, in decimal? So that would be 2 to the 0, 1, 2, 3, 4, 5, 6, 7. So that represents the number, that represents the number 2 to the 7. So, okay, so that's the exponent. And then next we get the significand, and that is given by all the remaining bits. So where did we say? Yeah, we said, I think here is where it left off. And so now if we copy paste that, and we probably want to think about what number that is. So that is going to be, or maybe we'll think about that afterwards, right? Because I want to maybe think that this is really, supposed to be interpreted as, 1.011, so on in binary. So that'll possibly make things easier to compute when it asks us to eventually decide what the decimal value is. So let's move on to that part actually. So we've identified the sign, the exponent, the significand. So we move on to identifying the what is the decimal. And so we know it's going to be negative because of the sign. We then know that, right, the whole point of the exponent is to indicate 2 to the 127 minus the bias, right? If I am remembering the order of those correctly. Or okay, so I think I have it the other way around. So it's 2 to the exponent minus bias, and the bias I believe is 127. Yeah, 127. So let's just write out this formula as that we are going to have, let's say 1 plus, or let's just say 1.011. That's written in binary. I mean, if we want, I could say like sub 2, or maybe preface that with 0b to indicate that that's a binary number. And the 1, right, the 1 plus, right, by putting this 1 on top of the significand, which starts here, and I don't need any of the following digits just because they're all zeros. but putting a 1 at the front of that is basically the implicit one that we talked about in a previous video. So that's that. We are further going to take that to the exponent of the exponent, which we decided was 128, and then we're going to minus the bias, which we said is 127. And so that is our number, but we still want to continue taking that significand and taking it out of binary and into decimal. So that is going to be the number negative. Now the 1 is just a 1 because it's in the ones place. And then the next digit is a 0, so it gets us nothing. But the 1 after that is going to essentially represent a 1. Maybe I'll even write it as 1 over 2 to the 2. Actually, maybe it makes even more sense if I'm going to try to display this to represent it as 2 to the negative 2. And then the next one is going to be plus 2 to the negative 3. And that is our number. And then this is negative, let's say 1, and then what? A fourth plus an eighth. So maybe let's just keep computing it that way. So let's say, whew, man, this is buggy, whatever this is. Anyway, let's just come down here. Okay, so equals 1 plus, let's say, frac 1 4 plus frac 1 8. And that's supposed to be negative. And that is, let's put everything over 8. So that's going to be 8 plus 2 plus 1, so 11. So that's frac 11 over 8. Okay, so that is our decimal value. And we could compute it with like digits if we wanted to, but that just seems not the most interesting thing. So that is question number 2. Should we do question number 3 or save that for the next video? Consider the following struct. Draw the contents and the layout of a variable of this struct type, assuming that the variable is placed in memory, starting at this address. Okay, so, maybe I'll just talk this out because I don't want to, go through getting my drawing stuff right now. But if the starting address, right, the variable is at this address, with F's followed by EA0. Well, that's going to be the same as the address of this char. Now, the char array has this field name, and it's got 8 chars. That means 8 bytes. Every address is 1 byte. So if we took this address and add 8 to it, that would mark basically like the end of the name address and the start of this unsigned int flag address. So, right, I would basically just draw a box of width 8 starting from this address and then going up to this plus, like let's say 7 to be the last thing in the name array, and then this thing plus 8 would be the beginning of my int variable flag. The fact that it's unsigned doesn't matter. It's still going to, right, an int is still going to take up 4 bytes. So I would go 4 beyond that address, right? So with this, having added 8 onto this, I would then add another 4 onto that to find the first address of the next thing. That's a float. A float takes up 4 bytes, so we add another 8 to make space for max, and then we add another 8 to make space for min. And that would be everything that's in my diagram, just, computing these hex addresses, by adding the numbers that we just talked about, right? So adding 8 and then 4 and 4 and 4. And those would mark the beginnings of each of the addresses in this struct. Okay, so since we've talked through questions 2 and 3, but maybe this is already a little long, perhaps, then we'll save question 4 for the next video.